Okay guys, so once you get signed in, okay, you'll see the Chemical Reactions Lab in the Class Work tab under Labs and Projects, okay? And in there you will find that there are a couple of YouTube videos. I'll probably be replacing this 33-minute one with what I record right now, okay? It's the older version of this, but this is the observations video. You're not going to need that until after we've done the lab in case you're not here, or if you want to just double check any of your observations, you can use that video to do that. Okay, there's the PDF, which is just the lab sheet. That's what I'll have up on the board. Okay, what you need to be working out of is your Google Doc. Okay, right now, same as we did before. All right, now you're going to find that there's a lot of similarities between this lab and the one you worked on previously. The big difference is, on your first lab, you had to write up the procedure. That is the only time you will ever have to write up the procedure in this course. The rest of the time, the procedure will be written for you. Okay? So, that takes a little load off. Or a big load off, whichever. Okay? When it eventually loads. You guys get yours to load? No. Not loading for you either? Okay, so small glitch there, guys. All right, so this is what your template looks like. Okay, same as last time. Right? Remember that the problem needs to be restated in your own words. I'm going to go over that in a minute. Okay, we're going to talk about the variables. Right? You need to identify and explain. Okay, I still had a few people in the labs I've looked at so far who forgot to explain. Okay, you got to explain your variables. And then the if, and then part for the hypothesis, and then we'll get into these predictions here. Okay? All right, so the problem we're investigating here basically is how can it be determined if a reaction has occurred? Or what are the signs of a chemical reaction? Or what happens when a chemical change occurs? Anything along the lines of knowing or the indicators of a chemical reaction or chemical change. Okay, so in your own words, something about how you'll know if a chemical reaction occurs, okay, without using the word you. Okay. So like, how can it be determined, or what are the signs? Okay, something along those lines that don't require you to use the word you. Okay, now to help you with the variables part, the experiment is going to work like this. There are going to be a bunch of chemicals on the front table, same as last time. Except this time, they'll be labeled with their actual chemical formula. Okay? What's going to be done is there are going to be pairs that you are going to have to make in a little watch glass. Okay, so instead of having the tiny little depressions like we had there before, you're now going to have a watch glass which looks like this. Okay, it's like a giant contact lens. It's about this big around. Okay, and you're going to do the reactions in that watch glass. You'll have a big space, okay, and more of this stuff, because obviously some of our sources of error were that we had small amounts of everything. It was difficult to do in the little depression plate. Okay, so we're going to do all the reactions in this watch glass and rinse it in between. Okay, so there are going to be, okay, these unknowns at the front. Okay, and they'll all be labeled, as I said, with their chemical symbols. Okay, and what we're going to do is we're going to mix together the pairs listed in the procedure. Okay, so each time you go through the steps of the procedure, you'll be mixing a different pair of reactants together. Okay, I'll say that again. You, as the experimenter, are going to be mixing different reactants together. what do you suppose, as the experimenter, you will be watching for each time you mix things together? Well, oh, sorry, that you're raising. Since this lab is all about chemical reactions and the signs thereof, what should we be looking for?
Like color change and precipitate forms or...
Right. We should be looking for changes to happen, and then obviously having a list of those would be a good thing to have maybe in the then part of the hypothesis, but obviously we're not there yet. Okay? So each time you mix together these different reactants, you should probably get different signs of a chemical change. Like those signs might respond to the thing you put together. Hint, hint. Now, in order to be fair, or let's say to run a controlled experiment, there are probably some things that should be kept the same during the lab or during each new reaction. What do you suppose are some things that would be good to keep the same?
The amount of the substance you're mixing together.
Yeah, okay, I'd say that's a good idea. And maybe, if we look at this picture, okay, we might be able to determine exactly how that's going to happen. Okay, all of the solutions have eyedroppers in them. All the eyedroppers are the same size, which means anytime you mix two of those together, you'll be using the same amount because you'll use the same device to dispense the materials.
And we need two controlled, right?
You need three. Okay, remember, for each controlled variable, you need to say how you're controlling it and why. The why part is how it would affect the experiment if you didn't. What's something else that might stay the same in the lab during the experiment?
Temperature.
Yeah, I'd say temperature is probably something that's going to stay the same and could probably affect the experiment.
What are the beakers filled up with? Well, not the beakers with the triangular appearance.
So the Erlenmeyer flasks?
Yes.
Yeah, those have some of the reactants. Some of the reactants are already in solution. Some of them are solids. Okay, the ones that are solids will be dispensed with a scoop. Okay, so we've got like this is sodium hydrogen carbonate. It's baking soda, so you'll dispense that with a scoop. Okay, this here is zinc. It's just little chunks of metal, right? And all you have to do is take one of those chunks. It's about how much you would get in a scoop and put it in your watch glass, okay, to mix it with what you mix it with, right? The only one that's going to be an oddball is this stuff here, phenolphthalein. Okay, if you've watched CSI, it's what they use to detect blood. So if they swab something with the Q-tip or the swab, and then they drop that clear stuff and the swab turns pink, okay, that's phenolphthalein that they use for that. Phenolphthalein changes color around the pH of human blood. So it goes from being clear to being pink, okay, when it changes its pH. So we use it as an indicator. It tells us approximately what the pH of something is. Okay? So we'll be using that, okay, and for that we'll dispense 4 drops, which is roughly equivalent to what would be in the eyedropper. They're just in their own containers. Okay? All right, you need 3 control variables. Okay? You can think of a third one. We've already talked about 2. Okay? You need to come up with a third one. Like I said, I'm weaning you off of giving you all of them. Okay. In a hypothesis, what 3 words have to go in a hypothesis? If, and, then. Okay. The if part talks about the premise that we're working on. Okay? In this experiment, the premise we're working on is that reactions involve changes. Now, somebody put it really, really well almost 300 years ago, maybe in some important theory that we talked about way back on like the first day. Okay, you know that Dalton dude? Okay, so I would say that the if part of your hypothesis should tell me what happens in a chemical reaction, not the signs. That's going to go in the then part. The if part needs to tell me what happens in a chemical reaction. And I would say that is put pretty well in the fourth point of the atomic theory. So when you're writing your hypothesis, the if part should talk about the fourth point. Just don't go, if the fourth point is true. I don't want that. Okay? Word it, put it in there. Okay? What does Dalton say in the fourth point of his atomic theory? A reaction occurs when atoms are separated, joined, or rearranged. Okay? That whole thing. Okay? The and part describes the experiment briefly. Okay? In this experiment, different reactants are mixed with the signs or the indicators of a reaction being observed. Something along those lines. You just need to say what we're doing. Okay? Don't say we. Okay? In this reaction, various reactants, okay, or different reactants are mixed, and the signs of any chemical change will be observed. Okay? Again, I haven't used the word we, us, I, you. Okay, the then part of your hypothesis, the then part is supposed to predict, right? So if reactions happen when blah, 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 and reactants are mixed together and the signs are observed, then here's how you're going to know. You tell me, how are you going to know if a reaction occurred? And I would say that how you know a reaction occurred involves talking about the signs you might observe that indicate a reaction has occurred. Okay, one change I'm going to suggest you make to your lab report is in the observations chart. Okay? I would suggest that you probably need to split this very wide column into two. So I would say there like that. Okay, so that you've got it in two columns here. And I would say observations before and observations after. Okay, you should probably have a before and an after for your observations. Okay, so if the two things you mix together were both clear, odorless solutions, you would want to list that, because maybe afterwards you get a foul-smelling precipitate, okay, or something like that. Okay. Okay, the thing I want to work on next are the predictions of our reactions here. Okay, so we're going to write out the reactants for all of the pairs that are listed in the procedure. Okay, and I already have the reactants, I think, listed in yours as well, right? Okay, so let's walk through what those should probably look like. Okay, so our first pair that we're going to mix, and you don't necessarily need to do these in order tomorrow. Okay, in fact, I would suggest that you start with a random one. Okay, the only two reactions that have to go in numerical order are 4, then 5. Okay, the reason 4 then 5 has to happen is because you actually use the product of 4 as one of your reactants for 5. Okay, so those are the only two you have to do in order. All right, so in order to eliminate a bunch of people needing exactly the same stuff all at the same time, it might not be a bad idea to start with, I'm going to do 3 first, I'm going to do 7 first, okay, and then not everybody is doing 1 at the same time. Okay, all right, so for pair number 1, we're mixing sodium hydroxide with ammonium chloride. Okay, what kind of reaction are we looking at here? Double replacement. Okay, so in a double replacement reaction, we should be swapping the metals. Agreed? What's acting as a metal in ammonium chloride? Ammonium. Remember, ammonium is that one polyatomic ion that behaves like a metal because it's positively charged. Okay, that would be that one. All right, so that would mean then that if we're predicting our products, that would mean that ammonium should end up with hydroxide and sodium should end up with chlorine. Agreed? Okay. Now, did I just make 2 different ionic compounds? Okay, do I need to drop and swap them? Yeah, okay. Ammonium is a +1, hydroxide's a -1, that compound is okay. Sodium is a +1, chlorine is a -1, that compound is also okay. Okay, so those are both swapped and dropped correctly. Is the reaction balanced? It is, yeah. Okay, so here's what I want you guys to do. You do not need to predict pair 4 or pair 5 because they involve phenolphthalein, which is an indicator reactions beyond what we do in Science 10. Okay? So we won't have to do 4 or 5, and you will also not have to write pair 4 or pair 5 in your analysis. Okay? Part of the analysis is actually writing out what actually happens in the reactions, because spoiler alert, not all of your predictions are going to be right. Even if you follow the rules you've just been working on that I taught you. Okay? Sometimes reactions don't go exactly as predicted. Okay? But what I would like you to do right now is take some time and predict what you think the products of these reactions are going to be. Okay? When you're writing these out, guys, to get the subscript numbers, okay, because I want the subscript numbers so we don't confuse them with the coefficients, okay, in Google Docs, okay, to get those subscript numbers, so if I'm like typing in here, if it lets me, it's not giving me the keyboard, there we go. Okay, if I want to do subscript, so let's say I want to go NH, okay, and I want to do a subscript 4, go to format, okay, text, and subscript right here. Then type in the number you want, 4, okay, and then get out of subscript, so format, text, undo the subscript, okay, now you're back to normal, okay, and you can go OH, okay, and then plus, and then we would have NaCl. Right? So you can type them right in there. All right, so as I said, you don't have to do 4 and 5 because they're already done, okay, in there in your predictions. But I would like you to do 2, 3, 6, and 7, okay? Pick what you think the products of those are going to be, balance those reactions, okay? And then you can use those tomorrow when we actually do the reactions and go, ooh, wait a minute, that one worked exactly like it was supposed to, but this one sure didn't, okay?
And we also do 1, right?
What's that?
We do 1 too.
Well, we just did one, I gave you the answers to one.
Oh, yeah.
So you guys can predict 2. Now, for number 2, keep an eye on this one. This is another one that's written oddly. Okay, so I'm just going to go to that one on here. Okay, so on pair number 2, this stuff here is hydrogen acetate. I know it's not written that way, okay? but it's because acetate is an ion, but it's also organic. Okay? Hydrogen acetate is also known as acetic acid, which when diluted down to 5% is vinegar. Okay? So when you buy vinegar in the store, it is 5% acetic acid and 95% water. Okay? The stuff we're using in the lab tomorrow is the opposite. Okay? It is 95% acetic acid and 5% water, so don't mess around with it. Okay? Yeah, it'll be like drinking a spoonful of Drano. Sure, it'll clean you out, but it'll leave you hollow inside. Okay? Yeah. All right. But it's going to smell like vinegar, big time. In fact, it might like curl your nose hairs if you were to smell it too closely. Okay? Hydrogen acetate is an ionic compound, but it's written backwards. If we were writing it like an ionic compound should be written, it would be H plus with the acetate ion CH3COO minus. Okay, so the hydrogen is acting as the metal, even though it's listed last. Okay, it's just a weird formula thing that you have to do with this one. Okay, and it's reacting with sodium hydrogen carbonate. Okay, hydrogen carbonate is an ion, HCO3. It's on your polyatomic ion chart there. Okay, so.
Is the first element on our chart thing?
Is-
Acetate?
Yeah, that
Yeah,
one.
it is. It's up here as well. Yeah, it's the first one, right? Because it's alphabetical. And hydrogen carbonate's right here. Okay, HCO3. Right, just so when you're figuring out the metals are swapping, because that's a double replacement reaction, you know what things to swap.
How would you balance acetate and carbonate?
They're not going together.
Okay.
Carbonate, hydrogen carbonate is negative. It's with sodium, right? Hydrogen is the metal here. That's why I wrote it like this.
I get it now.
Okay, swap the metals, and you know who goes with who on the other side. You know what, guys, let's just walk through that one because it's a little bit tricky. Okay, so in this one here, we're going to swap the metals. That means that sodium is going to end up with acetate. Okay, this is a -1, that's a +1, so that compound is fine the way it's written. Okay, and then I'm going to have over here hydrogen carbonate, which is weird. I don't want to write it like this. How do I want to write it? If I got two H's side by side, I should just write H2. Yeah.
How do you do the little numbers on computer?
So just do control either control comma or control period.
Control comma puts it subscript, or you can do what I showed up here a few minutes ago, where you go into format.
Yeah.
Yeah. Okay, now, when that's all done, okay, we've got sodium acetate, which is a salt. Incidentally, it's the salt that's used to flavor salt and vinegar chips. Okay, because obviously they don't soak salt and vinegar chips in vinegar, or they'd be all soggy in the bag. Okay, there's a salt that's got that flavoring on it. Okay, and then hydrogen carbonate. Okay, it would be the other product. Okay, is that one already balanced? Well, actually it is. Right? If I wrote the hydrogen carbonate like this, I have one hydrogen carbonate here, one hydrogen carbonate here, one sodium, okay? One hydrogen, one acetate, okay? Everything is already a 1 on that. Now, what's the other name for sodium hydrogen carbonate? You probably have a box of it in your fridge. Baking soda. What two things are we mixing together here? Vinegar and baking soda, except we're using lab grade. Okay? What did vinegar and baking soda do when you mixed them together when you were little? heavy bubbling fizz and whatever. Guess what? That's what's gonna happen. Okay, get signed out of those guys and put them back in the proper slot, please. Sorry, we're running out of time there.
Mr. Career,
Yeah.